Mr. Maswara. We are going to be doing proof number 4, and this is called opposite angles in a cyclic quadrilateral sum to 180. We're going to do a few examples and I'll show you how to prove it's true as well. Okay, so we have a cyclic quadrilateral with us here, and you can see it's a cyclic quadrilateral because all of the points or the vertices of the quadrilateral are on the circumference. So it's not just a random quadrilateral drawn inside a circle. All of those vertices have to touch the circumference. Now, you may have figured this out by the name that I've just introduced it with. You will notice that as we shift these around, the angles, let's pick a convenient one here. Oh, that's very convenient. The angles add up to 180 degrees as we move it around. Now, the thing is, this also applies for the other two angles which are opposite each other. So let's move this around so you can see they also add up to 180. So the name of this theorem is opposite angles in a cyclic quadrilateral add up to 180 degrees. And we'll look at some more examples and non-examples now. So here you can see there's a cyclic quadrilateral. I can move this around, and those two angles are going to add up to 180 no matter how I move it around. Now, when I show you the radii in this diagram, it's going to hopefully blow your mind a little bit because it's going to make a lot of connections with the first three theorems that I've shown you. So take a second to look at what's happening here. What can we say about these theorems? Let's just make it a little bit more convenient if you haven't got it yet. Yeah, so that's going to help us with our proof to show why the opposite angles in a cyclic quadrilateral always add up to 180. Now, a non-example of this would be if we had one of these vertices was down here in the circle somewhere. It's no longer a cyclic quadrilateral. So all four sides have to touch the circumference. Okay, so this is going to be one of the proofs which, again, you're going to be expected to be able to do from scratch. So I'm going to make some time for you to do the proof after I show it, straight after I show it to you. So let's say you're given a blank circle or potentially even just this that you can see on your screen, and you have to prove that x plus y is 180 degrees. So first of all, you start off with the thing you always start off with, and that is to draw radii. So you can connect these two up. Now, as I said, you can use previous theorems to prove later theorems. So in this case, we can say that the angle at the center is twice the angle at the circumference. Now, we don't have to go back and then prove that to be true. In this question, we're just focusing on this theorem, so we can use the other theorems without proving them as well. So then we can say, well, this has to be 2x. And it also means that this angle up here has to be, yes, 2y. Now, if we know that 2x plus 2y is equal to 360 because this angle's around a point, we can then factorize this out. So we can say 2 times x plus y is 360, and then we can divide both sides by 2 to get x plus y is 180. And that means that this angle on the outside and this angle on the outside, because they are x and y, they have to be 180. Mind blown. Okay, now, I want you to reproduce this proof just in a second. I'm going to tell you to pause the video. Okay, so let's say this is what you're given. Reproduce this, even if you just copied notes, do it on rough paper somewhere. Prove that the opposite angles are add up to 180. Okay, so there's your proof. So you should have got something like this. Now, in a real exam paper, you may not get x and y labeled for you, so you have to be able to label x and y by yourself. So you'll just be given just a blank circle or potentially not even a circle. Okay, now I want you to pause the video and try to figure out the angles here. So you're going to work out X, we're going to work out Y, and you're going to work out Z. I will show you the answers in a few seconds, so pause now. Okay, so working out the answers here. We know the first one is really straightforward. We know these two have to add up to 180. So you do 180, take away 92, so you get 88 degrees. And then these two have to add up to 180, so Y will have to be 110 degrees. Question 2 is a bit more interesting, but radii comes to the rescue again. We know that these two are radii, therefore DOC is a isosceles triangle, and that means that these two angles are angles we can work out. So 180 minus 96 divided by 2, so this will be 42 degrees. This will also be 42 degrees. Now we also know, if we ignore the triangle now, that this is a cyclic quadrilateral, and that this angle here plus this angle there have to equal 180. Now we know what it is. This is going to be 56 plus 42, which is 98 degrees. And then to work out this one, you do 180 minus 98, and that means Z is 82 degrees. I hope you got that correct. But we're now really getting into circle theorem questions here. So I will see you in the next video for proof number 5.